Our world is a big place. Planet Earth is home to 7.7 billion people, 47 megacities, and 195 countries looking to press forward. We all have distinct ways of living and thriving, but what we all share is a gaze to the future. This means thinking past borders, not just on land or across waters, but towards the boundaries of our planet. We're finally at the point where more than just a privileged few can go beyond the clouds. A growing number of players are blazing into the vast beyond, yet we're still just trying to figure out the best ways of leaving our atmosphere. Space is still, in the words of one famous explorer, the final frontier. But now more than ever, its realm is within each and every one of our grasps. This week, we're thinking about what it means to get to space now and in the years to come. Join me as we venture into new space. A big hello to everyone tuning in tonight. I'm Kate from Aalto Communications, and today on Way Out There, we're talking about new space, sustainable space, and the tech that makes it all possible. So we're really taking a close look at what the sector will bring now and well into the future. I have with me today Assistant Professor and Space Evangelist Jaan Praks, who's going to fill us in what these developments mean for me, for you, for the whole world. So welcome, Jaan. It's great to have you here.
Happy to be here, yes.
So, I think we need to start first things first. What is a space evangelist?
So, I've been calling myself with this a bit peculiar name because I've been going around in many places in Finland, like organizations, schools, universities, companies, telling about what is new space, what's happening in space at the moment, what are the small satellites, and why this is so important. And it's a sort of missionary who is going from place to place and telling the story. And I really believe that we are living the times when the whole space scene is going to change for the benefit of all of us. And I think this change is significant, and we should take advantage also of this change. So that's why I'm calling myself like this.
Well, it's a great title for sure. Now, you used a word that some people probably have heard recently, and that's new space. Can you fill us in exactly what new space is?
So we were talking today with one of the colleagues about this new space terminology as well. And it was the first like a joke, like the really young guys who try to do space in with a different paradigm than the old big space companies. And they were called old space. And of course, these young people, like it was like a teenage of this new evolving, more commercial, more cheap, more agile space technology. They started to call them new space. And first it was really like even like a small clash between old space and new space, because old space didn't want to be an old space and new space wanted to be a new space. But nowadays, as we see that this new space movement many things has been adapted by different companies and even science. It's more like a name for a paradigm of making space technology faster, much cheaper, and smaller. And it makes possible for many players which were not able before to make spacecraft or make space-based measurements or taking space-based images. Now it's possible to do it. And this is called new space. So everybody can go to space with a very small satellites, and this is called new space.
So it's a big paradigm shift, essentially.
I would say so, yes.
Yeah.
Because what is happening is that the miniaturization of our technology makes possible also to make satellites smaller. So no big deal, but rocket launches are charging from the satellite launches on the kilogram basis. And if you make 100 kilogram satellite instead of 3-ton satellite, you pay a lot of less. So it brings huge amount of savings. And instead of one satellite, you can launch 5 or 10
or more,
or even 100. And this is really can be called like a paradigm change.
Absolutely. And if we think about what we understand to be a satellite, we think of something quite big. I think most people do, at least.
Yes, yes. Satellites have been pretty big. So a size of a car, let's say. A big car, there are satellites which are as big as a bus.
Right.
And let's say International Space Station is even like as big as a train. And then there are also satellites which are like really small, like Italian Mini or something like this, or British Mini, Italian Fiat. But nowadays we can do satellites which literally will fit to your pocket.
Into your pocket.
Into your pocket.
Like my jean pockets.
Your jean pockets. It's called Pocket Cube. And it's a fully fledged satellite. So that describes how small you can go nowadays. Of course, these very small satellites are not so powerful as the very big satellites. They can do a bit different things, but still it's a very significant change.
Absolutely. Now we actually have an example of something that you're talking about. Can you tell me what this is?
So this is an example of a CubeSat. So CubeSat is one of the flagships of this change, and CubeSat technology or CubeSat standard is first very successful small satellite standard. There has been more than 1,000 CubeSats launched.
Over
already.
1,000?
Over 1,000 CubeSats launched. And this one here is the first Finnish satellite, which was also made according to the CubeSat standard. And the beauty of this small satellite standard is that first it's small, but you still can do many things with this very small satellite. And all these small satellites fit into the box which is attached to the rocket. Right. And that means you can change the satellites even last minute in these rockets without any problem. So this creates market. So rocket launchers, they provide these boxes, and you can put any of the satellites to this box, and if somebody is not coming, you put another one and you go to space and you have your satellites there. So even companies nowadays launching their technology, for example, Earth observation cameras with this kind of very small satellites, and launching of this small satellite is only a couple of €100,000 nowadays.
So that's a lot less than what a traditional satellite would cost.
So a big satellite, if you launch a big satellite, typically you book entire rocket or half of the rocket capacity and you pay tens of millions, even hundreds of millions. But for this one, much less. So this brings the change.
Absolutely, and this is actual size.
This is actual size, yes. This is Aalto-1 satellite, which was launched 2017, Midsummer Eve. Still works, has been there in space for 1.5 years. And as I said, there are more than 1,000 this kind of satellites launched. There is one company called Planet who operates exactly the same satellites. They have more than 100 satellites in the constellation, and they provide images of Earth with around 5-meter resolution every 4 or 5 hours.
Okay.
So it's really also a utility. It's useful for a company to provide these images on the market.
Absolutely. So when so many people are going to space in different ways, is the idea that there's a new space race? Is that true?
Yeah, there are many aspects. Yeah. First, what will happen with space is that space will be more like a commonplace. So we don't have, let's say, a governmental hairdresser or a grocery store which is regulated very heavily by central government or regime. But we have these kind of things for space still. So what will happen is space is going to be a normal part of economy and our society, and that means that commercial players will take over and provide these services, what we need in space, and the whole space will be like a normal area, like oceans. And we don't need very big organizations to go to space with one thing. We have many companies doing many different things. So, yes.
Yeah, it's funny because that changes how we think about space, because right now it's something so far and distant that you expect that it's not really that easy to get there, but it's really making it more accessible for all kinds of people and partners and so on.
It has been becoming much easier to go to space nowadays. And this is also, space has a brilliant brand. So if you can utilize this brand, you get if you claim that you go to space and you just make a small satellite, is as sexy as it would be with a big satellite. So this is, I guess, one of the reasons also why so many people and so many organizations are going to space, because you can get the benefit.
Yeah, absolutely. So what does this mean for the little guy if things are changing? We see more businesses, more interest in going to space. I know that this has probably been quite evident here today at Aalto University because of the Finnish satellite workshop, which is going on.
Yes, we arrange every year a Finnish satellite workshop, or actually we just arranged the second year in a row, and interest is really big. We have more than 400 people registered. We have more than 100 companies registered, and we have more than 70 presentations, 3 full days of very interesting program. And this just reflects the interest. Space is very interesting at the moment because space is providing so many opportunities. So there are opportunities to make business. So there are opportunities to make good science because a lot of interesting things have been not made before because it was too expensive to make everything. Now it's more affordable, and you can do like many more interesting projects in science, in business, even in education, public outreach, anything.
Yeah. What about people going to space? What is the situation? Because I have the sense that it's reserved for very, very rich people. Do you think that's going to be? Yeah,
there's a couple of companies who are working very actively on something called space tourism.
Right.
I really don't know, does it take off at some point or not, but the technology is almost ready. So first space tourists with some companies are scheduled to be launched this year.
Yeah.
So first space tourists will not go to the orbit. They will not stay in space very long time. They go to a very short sort of with the launch. They go to the space and have a 5 minutes of weightlessness, and then they will come down. But they will see the Earth from space, and they see the curvature and they see the atmosphere.
Well, that must be amazing.
It must be beautiful, yes. But let's say the next stop is set to Mars, but it's still a very, very hard technical problem. How to keep people alive and happy during this 1-year voyage in the spacecraft. And this is not an easy task.
No, I suppose it's not. It's very far. We are just learning how to get out of our atmosphere, really. What are the best ways?
Exactly. So, but what is happening also is we're going back to the moon, because if we want to go to Mars, we have to rehearse somewhere. So moon is just in the backyard. So let's go to the moon first. And we need to see a lot of activity now. China has been landing a couple of times already on the moon, and a couple of commercial missions are going to moon, and they are claiming that they are landing the moon this year. PT scientists from Germany is actually at the moment presenting in Finnish Satellite Workshop their plan to land to the landing site of Apollo 17 with their mission. So there is a lot of activity also on the commercial side going to the moon. But of course they are not landing people there. They are only going with robot rovers.
Yeah, to have a practice run of sorts, to go further potentially.
Yes. So as I said, this is the test field, and the goal is much further, Mars, maybe even further.
Yeah.
Yes.
Into the future, for sure. That would be very exciting. And anyone who's been excited about the popular culture representations of space exploration knows that you want to go further and further. You want to see new things. That idea of exploration is very attractive.
Yeah. This is the whole space idea is very much linked to the exploration ideas. And it's also interesting that most of these exploration ideas and space future visions are also sort of social utopias, that people are thinking about how the society is organized when you are flying in space to the new place, and so on and so on. Exciting.
It's incredibly exciting. I have to say, as a lover of sci-fi, it's very exciting for me.
Most space people are.
Yeah, absolutely. So Space exploration is definitely one huge benefit of going into space, so we understand more about our world, our universe, and so on. What are the other benefits of having increased presence in outer space?
Yes, maybe not in outer space, but let's see, especially close to my heart is Earth observation.
Right.
And our species has been spread so wide that we are inhabiting the whole surface already almost, and it has a strong impact also on Earth, on the climate, on the atmosphere, oceans, and so on. So Earth observation is a tool which can give you a very accurate information what is going on. So if we are just here in a local place in Finland or Dipoli or Aalto-Yliopisto, we don't have the big picture. So the only place where you can have the big picture is space. So I believe strongly that we need space for first being fully aware of what is happening in a global scale, and also then taking actions based on this information. So in this way, having a space technology solution in space, we can also manage our life on Earth better.
Right. So we can produce information to make better decisions.
Exactly.
So that's for governments.
And not only for governments, but also for different kind of companies, business, and so on. So you can see the whole big picture, and you can make your decisions based on the real information, not on your sort of beliefs or something which is not having so sound basis.
Right. That's an incredibly powerful tool.
It is. And also, for example, navigation, communication, many of these solutions are also based, especially if you want to have them global. It's mostly the cheapest ways put them to space, because space is everywhere. And you have a global tool automatically. And it's just way cheaper than having like, I don't know, maybe mobile phone masts all around the world, including oceans. Just not possible. But you can put your base stations to space, and then you have the full coverage.
Right.
Yeah. And this is also a brilliant business opportunity.
Definitely. And one business that's been highly successful that has connections with Aalto University is ICEYE.
Yes, ICEYE is one of the best examples of new space. So these guys started 2012 in Aalto University with a project of developing radar for very small satellites. And they really succeeded with this one, and they launched their first satellite and their second satellite last year. So ICEYE is at the moment the world leader of providing the smallest satellite-based radar imagers in the world. And this also describes how fast and dynamic is nowadays the new space field. That there is a startup company founded 2015, and 2017 they are launching 2 satellites during the same year and demonstrating the most advanced capability in the world with this kind of satellites. And ICEYE makes, with the radar images, makes possible to get images everywhere in the world, including Nordic, including Scandinavia, North Pole, where we have dark nights, snowfall, like today here.
Like today.
You cannot see anything, but with ICEYE radar, you just take a picture and everything is crystal clear.
Yeah, and the photos that I've seen have been incredibly accurate.
Yes, and ICEYE is building now the first synthetic aperture radar constellation of satellites in space, and this will have a lot of different kind of applications, from security, from navigation to everywhere.
Yeah, absolutely. It's a wonderful success story, for sure.
Yes.
So we've talked about the benefits and the very exciting developments that are still happening every day. What about the challenges? Like, what do we still need to conquer when we want to go to space?
Yeah, of course, it's still the price of going to space. This is a big threshold, so you have to have some kind of money to go to space. You cannot walk to space and put your...
It's probably a bit difficult.
Not necessarily, because The closest satellites are only like 350 kilometers away. So you can walk this distance.
Technically, I suppose.
In principle, but not to space.
Hard to go up.
Yeah, you vertical up, it should be. But there are also many other challenges. For example, if it's getting easier and easier to go to space, we're going to have more and more stuff in space. And all this stuff has orbital velocity, which is 27,000 kilometers per hour. This is much faster than any bullet on Earth. So that means that we have a lot of stuff in orbit which might start to collide with each other. And if they start to collide, we have a lot of small particles bouncing around and killing all the satellites. Yeah. So this is called space debris problem.
Right.
And we don't have a really efficient solution for this thing yet. So it's getting easier and easier to go to space. Everybody wants to rush to this market, have their solutions, and maybe get profit from this. And somehow we also clean up the highways in the sky. Yeah. Because if we are not doing this now or soon, we're going to face big problems in the future.
So give me a sense of how big the problem actually is. When we're talking about space debris, space junk in a way, is it stuff that has been sent up there and has broken apart, that it just stopped working? How big are they?
Yeah, space debris is anything. I mean, space debris can be anything which is in space. One of the big space debris particles one day is also International Space Station. But because it's so low and you can actually break the speed of the space station, you can probably pretty safely drive it down to the ocean and then nothing bad happens. But any particle, any upper stage of the rocket, any satellite or any part of the satellite can be space debris and can be a potential problem if it collides with something else. Yeah. And especially problematic are these very small satellites which typically do not have any propulsion, so they cannot alter their orbit. So if they are about to collide, they will do so. Yeah. And this is definitely a problem.
And what are the ideas to solve this issue as more and more people are going in some way up to space, into orbit?
So big space organizations, they have already actually agreed years ago that we should have some kind of rules on space debris, and we should be responsible and clean up the space also after usage. And there is something which is called 25-year rule. And 25-year rule means that after your mission is over, your satellite should not stay in space over 25 additional years. So we need to have a technology somehow which brings the old satellites down. Or even we might have a fast mission, let's say only 1 year mission, we go up, we complete the mission, and we will come down with the satellite. This kind of small satellite is just like hits the atmosphere and burns in the atmosphere, and there's nothing left from the satellite anymore, and problem solved.
So it burns up on its way down.
Yes, it's like a falling star.
Right.
It's beautiful. It's just a second, and then it's gone.
And we don't have to worry about it anymore.
And then we don't have to worry about it. So we need to have technologies how to bring these things to the low orbit, which will burn the satellites.
Yeah. So what kind of technologies do we have in store for that?
This is a big, tricky question. A lot of people around the world are thinking about it. There are many solutions also. So you can increase the area of the satellite if you are in low orbit. So if you go and get closer to the atmosphere, for example, if you are in 300 kilometers already, this kind of small satellite stays there only for half a year. Because eventually air drag will bring it closer and closer and closer to the atmosphere, and then it just bumps to the atmosphere and burns down. But if you are 700 kilometers high, it will definitely take more than 25 years, take 30 years maybe, 40 maybe. And we need for those satellites which are higher, we need some kind of system which somehow will make the drag and reduce the speed, and they will come down. It shouldn't make the satellite very big or very bulky. So maybe some kind of engine. There have been like ideas of big glue balls which will catch all the small particles. So there are many types of space debris. One is the active satellites, which you can steer, which often have some kind of engines, and you actually can drive them down. But there are also like bolts and nuts, literally, in space.
Bolts and nuts.
Yes, which
Tiny
you cannot
things like
steer.
that.
Yes,
Yeah.
yes, tiny things like that, and they are like going through everything, which is the problem. They have so huge kinetic energy because of the orbital speed, and you cannot catch them with anything. So, tricky problem.
Definitely a tricky problem. What about the role of intergovernmentals, governments around the world in solving the problem? Making some kind of agreements or...
Yes, and this often is made through the national space laws. Happily, Finnish space law is also a very progressive one, and also taking measures to mitigate the space debris problem. French law is very strict against space debris, for example. But some countries, like Germany, do not have even a space law. So it doesn't mean that you can do anything, but the rules are, let's say, more obscure.
Right.
And it's very difficult to make a universal space law or make any kind of universal law. We are still not very good in actually agreeing something totally internationally. So we don't have an international government, and we don't issue international laws. We can have sort of agreements, and we try to follow them, not with a very good results sometimes. And this is one of the problems, a regulatory problem actually. So how to make these kind of regulations that people also follow in order to keep the space cleaner for our future.
Yeah, and to make it more sustainable.
Exactly.
More people can go, more benefits.
Exactly.
Yeah. So tell me a little bit about e-sail technology.
Yeah, e-sail technology is a fascinating technology which has been invented at Finnish Meteorological Institute. And I'm proud to tell that also Aalto-1 satellite has one demonstration of e-sail technology. Just yesterday we were making some tests with Aalto-1 satellite in space, burning some logs and then taking some test data down from the e-sail. So for the small satellites, this e-sail technology can be used as a brake. As a brake. It will reduce the speed. Or, if you like, as a parachute. So it's a long wire or tether. This long wire is charged with an electric field, and this electric field will linger around this tether or wire like a sail. And all these charged particles, which are in space plasma, will be caught by this wire or the electric field, and this will reduce the speed of the satellite.
Okay.
And this is very interesting technology because you can cause the drag for the satellite with a very thin wire, which is not thicker than human hair, and you can cause this drag and bring your satellite down. It's the only trick is how to get this tether deployed, and this is what we are working with. There has been no satellite successfully demonstrating this technology before. Aalto-1 satellite is another one in the row which tries to do it. The first one was Estonian S-Cube 2014. And now we're going to have also next satellites. Our for-sale Center of Excellence in Sustainable Space has many satellites planned, which all have this space sail technology, which we first try to use as a brake. And in the future, this e-sail technology has a promise that it might be a propulsion technology in solar system, because with this kind of big sail structure made of wires, which is basically from technology point of view sort of easy. You can put wires. You can put wires in space. If you charge them with an electric field, you can catch the solar wind, and solar wind will be your propellant. It will blow your satellite wherever you want, very fast.
It sounds quite convenient, I have to say.
Exactly, and that's why we are really fascinated and excited about this this technology. We would like to demonstrate it as soon as possible and provide this kind of propulsion devices maybe in the future. There is actually one company already founded to take advantage of this technology. It's called Aurora Propulsion. But yes, there is a huge market.
Yeah, so we have this model here of Aalto-1, and you said that it has this e-cell technology on board. So how long would this wire actually be?
In Aalto-1 satellite, the wire is 100 meters.
So this is like real size?
Yeah, this is real size.
This is about 30 centimeters tall, I suppose?
Yeah.
So the wire is much, much larger than...
Yes. But it's like
thin.
Yeah, it's thin. It's like let's say, it's like a fishing line. It's like a fishing line inside the satellite. It's on the reel, and you just turn the reel and reel it out, and then you have a long wire, and then you charge it up with a high voltage, and there you go.
Yeah, and so your hope is that you can move it and then bring it down.
Yes, our hope is that we can spin the satellite in a certain configuration, that the tether will be stretched because of this centrifugal force, and we will apply the voltage, and this voltage will interact with plasma, and the result is that speed is going to be decreased. So it should take a couple of months, and we should be able to take the satellite down.
Well, that would be very exciting.
Yes, and but there's a lot of technical problems before you get so far, because you have to spin the satellite right, you have to have all the reel locks and everything in the right position and so on. So it's quite demanding, but it's exciting at the same time.
Absolutely, because you'll have a proof of concept.
Yes.
An out-of-this-world proof of concept, I dare say.
And it's actually pretty interesting that this simple technology, having this Coulomb drag in space, has not been thought before. So there are different other kinds of tethers and concepts used, but this is beautiful, especially because it does not increase the area of the satellite itself. So if you increase the area of the satellite, you are also increasing the probability of collision. But with this kind of very thin wire, it's so light and so thin that even if it collides with something, it doesn't make any harm.
Right.
So it's really a sustainable technology for bringing small satellites down if we get it working.
Yes, well, I'm sure that you will, with all the hard work involved. On that note, I want to thank you for being here today. It's been really great hearing from you and learning more about new space and sustainable space and the direction where all of this is going. It sounds really exciting, and I am sure that everyone has a lot to look out for.
Exactly, so we are excited as well, very much, and really happy to be here with you.
Yes, thank you very much, Jaan.
Thanks for having me.
Thanks. So I want to thank all our viewers for watching, our crew, of course, for making this happen. We'll be back here next week for the 4th installment of Way Out There. I'm going to be talking with Tuomas Savolainen, who's an expert in radio astronomy, and he's going to tell us why black holes, those big bad beasts, are a little bit nicer than we might think. So definitely come back, same time, same place for that feed. See you next week. Can't stop thinking about what's way out there? Watch the next part of our series.